Hello, everyone. This is Raphael Devrel at Atrium Academy, back again for our weekly public events. This week we have Brian from Agus, and he's going to teach us how to make our hooks irresistible.
That's right. Yeah. I was told not to use the word love, and so we went with use on the invite and switched it back to love.
Nice.
We can love hooks, right?
I love hooks.
Yeah. For a
So,
few years, we made one of the largest automated liquidity managers on Uniswap V3 and all things concentrated liquidity. But I'm so excited to talk about V4 because it didn't just add extra features, it actually turned the whole thing into a platform for this programmable liquidity, where you can ship the custom logic, risk policies, essentially UX, all at the pool level without forking the AMM. So I wanted to talk today about how to build hooks that people actually use. And of course, we have some ways of helping you. But again, I think just so we understand what's at stake, adoption is the bar. If routers won't simulate you, LPs won't deposit, if vaults and other systems in DeFi don't trust you, then it's kind of all for naught. And so what we're trying to do is get hooked teams from a clever idea to mainnet traction. And this is important as I think I saw there was like 15,000 hooks out there, but maybe just a few, less than five. And Aegis is one of those, has most of the adoption. And so our goal is to make your hook one that wins routes and deposits. I'm curious though, before we get started, we're recording this mainly for an online audience, but if some of the people that are here want to introduce themselves or can find out, I think it's kind of a tight-knit group of developers. I can better tailor this if I understand who's on the line. So if anybody wants to introduce themselves, let's just take a moment to do that.
Hey everybody, I'm Delion. I am the founder of Mantua AI. I'm building a operating system for programmable liquidity for DeFi. I'm here to learn about hooks, and looking to build my own for my own platform.
Awesome. Yeah, exactly the type of person we need here. Anybody else want to introduce themselves? Okay, well we'll keep going. Today we're going to anchor on the Aegis DFM hook. DFM stands for Dynamic Fee Mechanism. This is a hook that was selected by the Hook Design Lab originally. It's been audited twice now, and it is the leading hook in terms of blue chip liquidity and volume on Uniswap V4, like at least when it comes to volatile volume. There's more of them for like more volume for these stablecoin pairs, but when it comes to something like ETH trading against Bitcoin or similar, it's approaching $1 billion in volume since it started in that market. So what you'll get from this um, presentation is first I'll review some of the V4 mechanics that you must get right, and we'll talk through an adoption checklist through, thinking of all the various um, routers, LPs, wallets, lenders, things in the ecosystem. And then we'll present a little playbook where you can actually uh, embed a lot of what Aegis does into your hook without having to reinvent the wheel, so to speak. So just to talk about hooks and introduce people to the concept who aren't familiar with it, you can think of it as this middleware layer for a Uniswap v4 pool. It's just a contract. You attach it to the pool at the time you create the pool, and it can run logic before and after big moments. And these big moments are like when a pool is initialized, when liquidity is added, when you swap, or maybe if you're running some sort of reward campaign before or after donating to the pool. However, a pool gets just one hook, and that single hook contract can serve many pools, and this makes your hooks design effectively this reusable product primitive. Now, when that primitive is attached to a pool, V4 has to use the least significant 14 bits of the hook's address. And this is kind of like your capabilities badge. And when you deploy your contract, you deploy it in a way that these bits are mined, they're validated in the constructor, and that's how Uniswap Pool Manager knows when to run, say, before swap or after swap or one of the other hook callbacks for your hook. Um, we've seen dynamic fee management. That's one of the things we're talking about now. Cut on-chain limit orders, custom oracles, and even entirely new AMM structures and ways of sharing value, all delivered at this plugin layer. Now, in today's talk, we're going to use Aegis DFM as our running example. This hook has this two-part fee engine. So this base fee will tune over time, and it charges a temporary surge fee when volatility events occur. We call them cap events for like capitalizable adverse price. And so it uh, better protects LPs at the moment that they're most likely to lose money. And so zooming out, this hook ecosystem, it's growing fast. Again, thousands and thousands of customized pools. Integrators are standardizing, and there's this huge opportunity. This, if you can create hooks that have adoption, and that adoption path is what we're designing for today. Um, because these things are all just highly leveraged to who uses them, not exactly what the killer idea was. So let's review some of the other V4 architecture patterns beyond these hooks so that you can see why this feels like a platform, not just a DEX upgrade. It has this singleton contract. This is like this one big contract, a clean execution model, and some gas savings tricks where all of these various pools hopping between them becomes, it feels free because all you're doing is scribbling down in this one contract what happened. Every single pool lives under that single pool manager. That means there's one reentrancy boundary, shared accounting, and cheaper composition. Routers basically string together actions rather than bouncing tokens across many different contracts. You could think of it as like the central station for all the pools. Now, that's the singleton pattern. If we think about flash accounting, during your transaction, V4 tracks basically who owes what instead of moving tokens around, and it calls it deltas. So you can swap A to B to C to D and only settle the net once at the end. However, these net deltas must land exactly at zero or the whole thing reverts. So you can think of it as like accrue deltas, do all your steps, settle once, lock it again. That's how you could think about the mental model. And then finally, this EIP 1153 storage. This is kind of like the fuel of the whole system. It's cheap, it auto clears at the end of the transaction and turns many writes into one final settle. So this is perfect for multi-hop, swap and add, liquidity combos, and things like that. So this is all tied to adoption because routers will get deterministic low gas paths. LPs see more volume due to these more viable routes. and there are fewer mysterious fails. So this is why you've seen thousands of these customized V4 pools spin up so quickly. Uh, so now that the engine's clear, and again, I think some of these features uh, are almost more exciting to me than hooks, which I guess Uniswap v4 is known about. But let's talk about how permissions and fees happen in this flow. So again, they're like the capability badge. They're encoded directly into the address. It's what makes your behavior predictable and auditable. So I know early we tried to create a hook that would turn all these things into, basically turn them all on and then make another governance layer higher up. I don't encourage that type of design. That's why we moved away from it. Because people want to know exactly which callbacks um, are likely to fire today or after an upgrade, and they don't want the functionality changing on them, right? So basically, if you only turn on the hook callbacks that you need to use, then use them in a specific way and avoid leaving a bunch of open ones that you're going to have to answer questions about or raise governance concerns. Now, uh, the bitmap is ultimately going to be irrevocable for that address. So you can't add new callbacks via later upgrade. The pool manager will never call them unless those bits were there from day one. And that's why publishing your mined address is so critical, and those flags are what builds trust. Now, the Aegis DFM hook keeps its surface area incredibly tight. We only turn on swap-only permissions. The constant product math is untouched. All deposits and withdrawals aren't touched either. And so this minimal explicit bitmap is why routers are comfortable simulating and routing to it. Other analytics displays or wallets can display it cleanly, and it's one of the reasons we got such great adoption early on. So integrators, they basically can spot that it's a hooked dynamic fee pool. They can understand uh, the risk surface really cleanly, and you want all of these permissions documented in your README, and you want everybody to really understand the capability badge that you're displaying for your hook. Hope that's the importance of that is clear, because a lot of times we want to have functionality or like things plugged in that we later want to take advantage of. I don't really recommend it with hooks. Um, the fee architecture, if we dive more deeply into how value can be shared, there are three distinct categories in V4, and you need to keep these lanes straight and your integration sane. So the LP fees, these are the ones paid to liquidity providers. In V4, they can be static or dynamic. Dynamic means that the hook sets the LP fee per swap, per block, or on a schedule. V4 doesn't determine or prescribe the formula, your hook does. So that's why routers need deterministic reads from you. The protocol fees are separate from the LP fees. You could think of that as protocol revenue toggle. Don't conflate them with your hook logic or LP earnings. And then finally, our hook fees, this is extra accounting that you can put there for your hook to skim, split, reinvest, or return these deltas in swap callbacks. If you do that, if you're actually taking some hook fees, it's very important to emit clear events and document how you did it so that all the dashboards and everybody else can keep up and trust your hook. So one more thing on the dynamic fee. there's actually a flag that you have to set. I put it on the screen here. This flag will let V4 know that this fee can be changing. Um, so Aegis, basically what it does is it computes an effective LP fee as a base fee that is determined by long-term volatility of the pool. Now this occurs entirely on chain. Routers can know when they calculate effective fee that they're going to pay less than or equal to that fee, um, unless some other trade jumps in front of them, and we can get into what some of those other conditions are. But routers are used to worrying about trades jumping in front of them and changing slippage and all sorts of things, so that's not a problem. What we want to avoid is unpredictable behavior, even if something doesn't jump in front of you, right? And so that's how the fees are cleanly separated in Uniswap, and we'll talk a little bit more about how Aegis counts these dynamic parts and why the bounds and cadence matter. So um, when a volatility occurs, right? So what happens in DeFi or in one of these pools is that maybe a president or somebody makes this tweet about something in the world, and the price moves in one direction at speed. DeFi always lags that. And so what's going to happen is people will come in and make a huge trade. But that's not the only reason a huge trade might occur. Sometimes people make a huge trade just because they're incredibly price insensitive. In some cases, they may have like even stolen the money and need to swap all at once. In other cases, it maybe some liquidation is happening in some part of DeFi, or somebody just doesn't want to split their trade up into many pieces. Um, no matter what happens and why that big swap was triggered, Aegis is designed to profit from it. So in the case of it being this huge market movement, that surge fee will stay for a period of time, but linearly decay back to zero. So maybe over the next 12 hours, it starts high and goes back to zero. If it was this big price insensitive trade, the the arbitrage back to market price will pay 4 or 5 times more fee than the first price insensitive trade. And so you actually want to attract that price insensitive trade by giving them a good deal and then charging the arbitrageurs to restore the price in the pool. And so both of these ways of making up value uh, lead to better markouts for Aegis than competitive pools, and then therefore LPs would rather LP into an Aegis pool. All this happens without any off-chain components, none of those bips that may flip on or off, or logic that people can't understand, which helps with adoption. So let's move on to just the importance of how the routers work. If they can't quote you deterministically, it won't route through you. And so Aegis was built for these solvers first, and they can get this single get fee state. They know that they're not going to pay more for that. Again, the trade after them might pay more, but they're not going to care about that. This cap trade is the one that moves the price, is the trigger trade, and that first follower pays more. Now, second, you want to get a sense for how much that, like how sensitive that cap trade detection is. And so the system keeps track of how many of these have occurred, and it adjusts the base fee based on the frequency of them, if it's not hitting a targeted frequency, um, the the sensitivity for cap events becomes much more sensitive. And if it's getting too many of them, the sensitivity will get less sensitive, and the base fee tracks with that. So essentially, Aegis is made to operate smoothly in all market conditions for all pools, while also benefiting LPs directly when this is on to security. In V4, you don't just like drip tokens step by step. You unlock the pool manager. V4 calls the unlock callback, and you do all your actions, swaps, modify liquidity, tote, etc., and then relock. Uh, and you're only able to succeed in this if at the end all of these deltas are back to zero. Um, you should protect these callbacks with a safe callback guard so that only pool manager can execute your hook functions. So this blocks rogue external calls, short circuits, this whole class of reentry and permission bugs. You should remember that the flash accounting that relies on transient storage, it's per transaction state that's automatically discarded at the end. You don't want to depend on this transient value across calls. And then what you really want is to focus on this determinism, focus on this exit safety. Like Aegis can do nothing to stop people from getting their money back out of the pool. Actually, it can't even block swaps from occurring, because if you block swaps from occurring, you have a problem with understanding, well, who loses when you turn them back on. And so essentially, if Aegis is turned off for a pool, that pool works exactly the same as an unhooked Uniswap v4 pool. It returns to the original security state. And so with these safety rails in place, let's just talk about how to make your hook visible to people who need to use it. Um, and so to make it visible, you need to give UIs facts, not just like feel good. You need to emit clean machine parsable events for every meaningful change. In the case of Aegis, this is the base and surge fee parts. You all toggles, all hook charged fees. You want the math to be recomputable on chain so that analytics can verify all of these numbers without you. Name fields so that the indexers don't don't have to write one-off parsers. You need to speak the ecosystem's language. So Uniswap has published hook data standards with standardized vocabulary, consistent field names, and shared expectations around the 14-bit flags. So this clarity is a major reason that Aegis is able to get the routers to adopt it. You want your pool discoverable, right? And so the clearer your signals, the safer the UX for everybody. And you want to include all of these details in your docs, in your audit reports, so that wallets can and other integrators can verify all of the facts. So again, structured events plus standards equals faster indexing, accurate quotes, consistent display in wallets. So now that you're visible, like we've talked through the hook and how it's become visible. Let's talk about the fastest way to get into production. So one of the things that we did is after we fought through the creation of Aegis V1, we came out with an Aegis 1.1, and we're calling it the Aegis base hook. So Aegis, which already extends Uniswap's base hook, is now a base hook itself, and other projects can extend it and add their own functionality. So Brevis, which is they've made a hook for um, VIP discounting. Basically, you can give fee discounts to whitelisted KYC traders or maybe to routers to drive volume to your system. And they put their fee discounting logic on top of all the logic that we've discussed. And this made it possible for Brevis to benefit from all of the features, all of the uh, dynamic fees, the better LP profitability that we've discussed without having to build it all themselves. And so we think that rather than replacing or rebuilding this, um, I guess 3,000 lines of code that ends up being $100,000 or more to audit, you can benefit from those features instead of starting from nothing. Um, so I'm gonna show everybody kind of a little bit about Aegis in production. One second, I'm gonna pull up a few screens. Where did I put these windows? So here, does this one show up now? Raphael, can you see this?
Yes, I can.
Awesome. So we'll start with the website. We are highly focused on confirming that things work well and right with the first pull rather than expanding. I've seen other pull hooks have different models where maybe they quickly get to 5,000, 10,000 pulls. We actually have 99+% of all of our TVL in this single pool on Uniswap, the very first one. And we've been studying it intensely and working on all the routing issues. So here you can see the pool. The hook address is displayed in Uniswap. And notice that it has this dynamic fee flag. We actually had to work with Uniswap on a number of UI changes um, for because initially they didn't everything was built assuming static fees, and of course that's not the case here. One of the things I would say about that is the APR will be lower in calm periods than in volatile ones, and sometimes some days you'll come on here and see that it's far higher. Getting into the metrics we're seeing, um, here actually in this top, you can see the there's a base pool that we're comparing against and our dynamic fee pool. And as I move across here, almost all the time, the dynamic fee uh, charges 450 uh, basis points parts per million, which is basically a 0.045% fee. But you can see when I go far to the left, it was higher, and that's the end of a decay period. If you go to this chart, you can see all the cap events that have occurred. So these moments where this fee went from 0.04% to 1,006 or 0.16%, almost quadruple the amount, and then back down over the subsequent hours. These are the periods of time the system has detected volatility and decided to charge more, and you can see the total fees charged over time. Now, we mentioned that the routing issues, so you can see early in this hook's history, this is just for the Uniswap Universal Router. Initially, the base pool, the competitive pool, was getting all of the volume. And over time, working with the Uniswap team and figuring out why, eventually um, the dynamic fee pool gets all the volume. And that's also the case when we look at different routers. So here you can see that Uniswap's router picks our pool 79% of the time and when it comes to volume. This MEV router does 93%, Relay router 88, but then there's others like here's Paraswap. This one never picks our hook yet. And if if your hook isn't picked by the first router to send the trade to the AMM, you that other pool that actually benefits twice because it got a trade it shouldn't have gotten, and then it gets another trade it shouldn't have gotten when a a um, atomic arbitrage contract goes in and corrects the price back. And so this was a kind of a difficult few months as we worked through all these routing issues and tried to understand them. And we're happy to assist any hook building on top of Aegis base hook in figuring out their router issues as everybody will want to use and actually has volume. And then finally, what we've seen is um, the P&L for LPs as routing has improved. Um, here, and I have this chart split into different types of trades because again, you don't want to compare the times your pool is getting unfair treatment, and that's by just a router that doesn't understand it sent the trade to the wrong place. And so comparing only atomic arbitrages, which aren't picky, happen super fast, and don't have any of the routing issues, you can see that the Aegis V4 profitability is more than double that of its peer pool, right? And it shows other wrap Bitcoin tokens here as well. And that's during these surge periods where that fee went super high. Even in the calm periods, it's also beating the other hook by quite a bit. In fact, I mean the other pool, the unhooked pool is actually negative in the calm periods with atomic arbitrage, and our pool has a positive um, P&L even in those calm periods. So that's the evidence that it's working. It's why we made version 2 with creating it into this base hook and looking to expand by offering it as a substrate to all the other hooks in the ecosystem. So going back, I think just to kind of go into closing, um, just the heuristics as recap. I think that you should extend instead of forking. This is true for Uniswap v4. It's also true for the base hook. You can have more profitable LPs, better routing if you do that hook logic on top. It's basically the shortest path to production and wide adoption. Um, the Aegis routes win because it's bounded and predictable. So I think helping advise the people who build on top of Aegis which hook callbacks they should consider, how they should use them, how it fails safe is very important. Um, Giving routers this single source of truth. Now, I know that there are a lot of hooks that were intending to play with custom accounting or math, but I think overly complex invariant logic or abandoning the x times y equals k curve should be very carefully considered. The benefit must be incredibly strong to mess with those things and make things less friendly for audits, routers, wallets, etc. But I think if you ship your custom code, your hook idea on top of Aegis with these principles, your hook will be more quickly quotable, displayable, and safe, turning your, I guess, clever idea into something that is widely used. So that's all I had, Raphael. I'm happy to take any questions. Appreciate the chance to be here.
Yes, yes. It's beautiful. Um, Complexity kind of kills at times, right? It's
Yeah,
you kind of want to, push the boundaries and be on the frontier, but especially in DeFi, you can get wrecked.
exactly. Yeah.
Yeah. Um, I guess I had a couple questions. when the fee rises on one pair, it just allows the other pair to like get a better price, and that's what routers are like why they're funneling their swaps your way.
So what you have to classify trades into mentally just to understand your ideal game theory is does that trader know something you don't know, right? And the people will separate that. They'll say it's informed trading flow or uninformed trading flow. That's what you want to know. And you want to attract you
I'm sorry, lost
basically
you for a
if
bit.
the
Lose them again. Ryan.
hey, I think it just yeah, got booted. I'm back.
Cool.
Yeah. Okay, what I was trying to say is you want to charge the informed flow as much as possible. You want to give a discount to the uninformed flow so that whatever router they're using brings it to your pool, right? And so that's what Aegis is designed to do. In normal calm times, it's underpricing the other pools and getting more volume as a result. But when one of these trades, big trades occur, uninformed or not, it's going to suddenly start charging a lot more, not just a little more, a lot more, and trying to maximally tax the informed flow that returns the pool to market price or tries to keep up with market price.
Interesting. Okay. So like that allows like Aegis to be like this really like the source of truth. Like it knows like the
It,
pricing flows before they kind of
it,
happen.
yeah, it doesn't really know anything other than something big just happened. And what I'm saying is that big thing that happened is only one of two situations. A
Gotcha.
large uninformed trade that we managed to attract,
Hmm.
which case a large informed trade is going to return our pool to market price, right?
Hmm.
So this is just, we're going to tax it on the way back as much as we possibly can. Or we've entered a new volatile period of time where informed flow is going to be doing its best to update the pool as market sentiment rapidly swings one way or the other, right?
Gotcha.
So in both cases, our our reaction is the same, charge more. It's just the maximum fee is charged on that first informed swap back if it occurs. And then over that subsequent, like highly volatile period of time, the longer you get from the disruption in market, the calmer things get. And so it just linearly decays back to zero. And we don't
Gotcha.
know exactly how long it will take to get normal again. When we first put the hook out, we used 3 hours. We later found that 12 hours would work a lot better. So you kind of learn that, but it's, yeah.
Interesting. Nice. Nice. Okay. And those and that decay, it shrinks like the size of those caps that you were talking about.
Well, so a cap is how far the price moved. Like what
Hmm.
is the maximum price movement before we charge the surge?
Hmm.
The decay of the surge fee is just
Um,
if it started at 4 times base, it goes back to base over the next few hours. Yeah,
gotcha.
yeah,
Caps kind of just like the delta
yeah.
in the
So it's
price.
how far the price moved and then how much more you charge because it moved. Those are the
Gotcha.
yeah. And again, there are a zillion theories and ways that people have attempted to do this in the past. I won't get into all of them. Most of them involve off-chain mechanisms. We completely ruled that out. Um, Second, I don't even think off-chain mechanisms help because if you take that first way of profiting, which is I want to profit on the return swap, that happens in atomic time. It's in the same block. The MEV block builder put everything together and it probably even sandwiched the large transaction, and you have to be in the middle of that raising your rates. So some sort of like off-chain monitoring system isn't even fast enough to be useful. And even if it is incredibly smart, it's probably not smarter than all the things occurring in DeFi, right? And
Yeah.
so I think a lot of those things just simply are too complex and don't work. We went with what we thought would be uh, uh, the approach that gets like 90% of the value with just 5% of the complexity.
Yeah, yeah.
And then most of the complexity is around making even that simple logic happen and making it acceptable to routers. And the thing that we added on that just comes for free is you have a price oracle. So now the rest of DeFi can build on you. But more than a price oracle, it also reinvest a share of the fees in locked full range liquidity. And so there's no way that that price oracle uh, trades out of range and stops functioning, which was a huge problem in V3. So we just went to make the pools as profitable and robust as possible for the rest of DeFi, including whatever Hook wants to build on top of us.
Nice.
Yeah.
Nice. Um, Besides Brevis, are there any other teams that are building on top of Aegis?
Um, None that I can announce right now. Yeah. Yeah.
The smart ones are, huh? Cool,
Yeah.
cool.
Yeah. So yeah, happy to hear from any out there, and we're happy to help people get started on their Hook adventure.
Where
Cool.
do you get the data that lets you know that there's only like of all the hooks that are out there, there's only like four or five that are dominating the market?
I ran that on Dune Analytics, but if you send me a message on Telegram, I'll share my report with you. Yeah.
What's your Telegram?
It's at GTFANN. I'm a Georgia Tech fan. Somebody took the Georgia Tech fan with one N first.
Right here.
Yeah. All right. Anything else?
Yeah, any other questions for Brian? Yeah. Aegis is cool. Like these are like you're just going with the flow. Like give the people what they want, give the swappers what they want. Don't
Yeah.
be surprised when everything works properly.
Well, yeah, the I would say it's kind of one of those things with great power comes great responsibility, and things get more complicated because you have so much power. You have to lock yourself down.
Yeah. Cool. Well, if there aren't any more questions, once again, thank you, Brian, again for coming through. Um, can't wait to see what's in the works with Aegis coming forward. Thank
Sounds
you.
good. Thank you, Raphael. Thanks everybody else. I hope you have a good day. Bye.
Bye.